Hello everyone, good afternoon, welcome to board Brahmastra. So this is the concept wise this is going to be last topic from the board Brahmastra series, and after this we are going to start with the revision, like a quick fast revision, okay, like a sprint. We are going to start it just after 2 days, and today there is a last session, so be very attentive because this topic, alternating current, it is subtopic in the magnetic effect of electric current, and it is a bit confusing for a lot of students. So if I give very simple, very easy questions to solve, sometimes students get confused. So be very attentive and focus. So let's begin. So first of all, do you know the difference between direct current and alternating current? Direct current, or in short, can be written as DC, and alternating current can be written as AC. DC and AC. So till now in the electricity chapter we have used a battery. You remember battery? That symbol for the battery is for the DC current. And what is AC or alternating current? The current which comes to our houses, that is AC. This is produced in the power station like hydropower or thermal power station, and that electrical energy which comes to our houses, that is in the form of alternating current. Okay, so now there is a voltage versus time. So what do you see here? Any difference? This constant voltage is our DC, direct current. Direct current has a constant voltage. So with respect to time, voltage does not fluctuate for the DC. And how for the AC? You see there is a like a sine or cosine function. You have learned in trigonometry, correct? The sine wave or the cosine wave. So there is a wave. You have learned the wave properties. I hope you guys remember. So whenever the voltage is oscillating periodically, then we say it is a alternating current or AC in short. So let's understand more about these two. You see here, there is a direct current. We use the battery. Whenever we have a battery, there is a DC, and this symbol is used for AC. So when you have the battery, you can show the direction of current. So current flows from, this is wrong, current flows from positive terminal and comes back to the negative terminal, correct? There is a unidirectional flow. But how about this AC? You see the current? These are the electrons. They vibrate or they oscillate. Once they are going to the clockwise, again coming anti-clockwise, clockwise, anti-clockwise. So they are like oscillating. So they produce waves. These are called as electromagnetic waves. So we'll study a little bit about it, not too much in details. So now what is DC? Direct current. So in the direct current, voltage is constant. In AC, that is the alternating current, voltage fluctuates periodically. So now in DC, current flows in the same direction, or it is unidirectional from higher potential to the lower potential in the DC. But for AC, current changes direction periodically. So for AC currents or alternating current, there is no higher potential or lower potential. Current only fluctuates. And there are wave properties of the, so AC is a wave. So if it is a wave, if something is wave, there are wave properties that we need to understand a little bit. So do you know what are the wave properties? I guess in grade 9th, you must have learned sound waves or the wave properties of sound. So the wave can be characterized using amplitude, wavelength, frequency, time period. So let's understand each of them. So what is amplitude? Hi Lina, good evening. So what is the amplitude? It is a maximum displacement of a wave or maximum displacement of a particle, or in case of electromagnetic waves, it is either electrical field or magnetic field. So what is the maximum displacement? That is called as amplitude. You see, there is an oscillatory motion. This object is oscillating. So this is the maximum displacement from the mean position. This position here This is called as a mean position. There is a mean, correct? So the maximum displacement from the mean position is called as amplitude. There is a amplitude. In both directions, the value of the amplitude is going to be same. Okay. So next one, it is the wavelength. You know this symbol? It is called as lambda. This symbol is for the wavelength called as lambda. So what is wavelength? You see, these are the two maximum and these are the two minimum. So wavelength is defined as the distance between two consecutive means just one after another, two consecutive maximum, and these maximum points are called as crest. These are called as crest, right? Two maximum or two minimum, they are called as trough. So these are trough. So the distance between two trough or the distance between two crest, that is called as wavelength. Okay, so there is a distance between two consecutive crest or consecutive trough. So now can you tell me what is the distance between trough and a crest? What is this distance between one trough and one crest? So I can show you here. From here to here there is a 1 lambda. So what is the midpoint of these 2 points? Midpoint is somewhere here, which is our trough. So the distance between trough and crest is going to be lambda by 2 or half of the wavelength. Okay, so this is the wavelength. And what is the SI unit? It is meter, because there is a distance, right? So whenever we measure a distance, SI unit is going to be meters. Yes, in sound you have learned, correct? Amplitude, yes, everything you have learned in sound waves. So we are learning this because alternating current is in the form of waves. These are called as electromagnetic waves, correct? So you might get a question on the based on this. So that is why I'm just quickly going through it. So the next one is time period. So what is the time period? Whenever an object is oscillating, correct? Whenever the object is oscillating, for this case electromagnetic waves, it is the electric field or the magnetic field, they are oscillating. So when they oscillate, what is the time period? It is a time taken to complete one oscillation. That is called as time period. So for example, if there is a start, the object goes in this direction and it has to come back, right? This is a one oscillation. If it starts here, goes to other end, that is just half oscillation. It has to come back, then only it can be said to be one oscillation. So the time taken to complete one complete oscillation is our time period. And again, because there is a time, SI unit of time is seconds. Okay. Now the next one, frequency. Do you know what is frequency? Frequency is number of oscillations per second. In 1 second, how many times the particle oscillates or how many oscillations it completes. So frequency is expressed in hertz. 1 hertz is nothing but 1 second raised to -1. So frequency and time period, they are related with this formula. Frequency is 1 divided by time period. Okay. So let's understand more about this. So there are advantages of AC. So why we are studying this alternating current? We were happy in electricity chapter. We have learned so much about direct current. But why AC? Because the power stations where the electrical energy is produced, so they convert either thermal energy into electrical energy or the potential energy of the dam in the rivers. They accumulate the water, then that potential energy is converted into the electrical energy. So why AC? Because those power stations may be 100 kilometers or maybe 1000 kilometers away. So the electrical energy has to transmit from the power station to our houses. And if it is a direct current, DC, there is a lot of wastage. So that is why we convert it in AC, we produce the electrical energy in the form of alternating current. So there is a very less loss. So energy can be transmitted with minimum loss, correct? Okay, so this is what it is written. So now in India, the AC frequency is 50 Hertz. So what is the meaning of that? That means, let's suppose there is a power station here, and let's suppose there is some small house. So what happens? So they are connected, let's say, by some electrical cables or wires. So the electrical energy, does it come directly to our houses or it oscillates? So the current, sometimes it comes in this direction and sometimes in the half of the time it is going away, coming towards the house, going away. So that is the alternating current. There is a AC. So if this is a AC with frequency 50 Hertz. So what is the meaning of 50 Hertz? That means in 1 second it completes 50 oscillation. So in 1 second it completes 50 oscillations. So there is one oscillation from the power station to our houses, then returning to the power station. That is one oscillation. So in 1 second, how many oscillations are there? 50 oscillations. So how many times the current changes the direction? 50 times it is coming to our house, 50 times it is going from the house to the power station. So the total number of times current changes the direction is going to be 50 multiplied by 2. This multiplied by 2, so that is 100 times. Current changes direction. That is the meaning of 50 Hertz. Clear? How DC is wasted? Because the direct current, there is a lot of leakage. So when you remember heating effect of current, Mohammed? So when you transmit a current for a longer distance, what happens? Because of the Joule's law of heating, it starts heating the wires or the cables, correct? When it heats the cable, the electrical energy gets converted into heat. So lot of energy is wasted in DC. In AC, you can transmit the power using minimum current. So in the high, you see in the cities nowadays, it is not visible, but there are high tension towers. So they do not have a lot of current. They have very high voltage. So you can reduce the loss and you can transmit easily. So that is the advantage of using alternating current. What is the difference in having higher Hertz rate? So in India, they have kept it to be 50 Hertz. So all over the India, wherever you go, the electrical energy is produced at the 50 Hertz, or alternating current will always have this frequency in India. Outside India, it might be 60 Hertz in some countries. Okay, so it is depending on the mechanism, electrical generator. That topic is dropped, unfortunately, or fortunately, I don't know, from your chapter. So in that, the faster, how fast the generator rotates, that will decide the frequency, and they have kept it fixed so that all the electrical devices can work at this frequency. Okay, so now let's solve some of the questions. So these are quite important because this alternating current, this is like a neglected topic in most of the times, but lot of good questions. I have seen the sample papers and lot of difficult or good questions, I would say, are from this alternating current chapter. So a pendulum oscillates 20 times in 4 seconds. There is a pendulum, it oscillates. So there is a pendulum which oscillates how many times? 20 times in 4 seconds. So what is the time period? So we want to calculate what is the time period. So what is the time period? Okay, so Sumed, if they use a generator, they mostly produce the AC. But if it is a small environment, for example, you are doing some experiment in your laboratory, in your school laboratory or college laboratory, then they use a DC because they do not want the current to fluctuate. If you want a constant current, you use a DC power source, or if you want to transmit the current for a longer distance, you prefer alternating current. Okay. What is oscillates? Oscillates means, let's suppose if there's some device, if I move this up and down, so that is one oscillation. Oscillation means something which is vibrating or moving from one point to other point coming back, that is oscillation. So pendulum, have you seen a pendulum? Pendulum moves, right? Something like this, that is oscillate, or that is vibration. So now it oscillates 20 times in 4 seconds, correct? So how many? So you can calculate the frequency. What is frequency? Number of oscillations divided by time, total time taken. So what are number of oscillations, which is 20 oscillations divided by 4, which is 5 hertz. This is frequency. This is not the time period. So whoever has written 5 seconds, that is wrong. These are frequency. And how will you calculate time period? Time period is 1 by frequency. So that is 1 by 5 these many seconds, which will come out to be 0.2 seconds. Okay. So the correct answer is option number C. That is correct answer. This is frequency is number of oscillations divided by time period. How many oscillations? 20 oscillations in 4 seconds. So 5 hertz, that means 5 oscillations in 1 second. That is frequency. And how will you calculate time period? It is 1 by frequency. It is the inverse. That is 1 by 5 seconds, which is 0.2 second. Okay. I know a lot of students, like I have given this question to at least, I don't know, more than 1000 students, and at least 80% of them get it wrong. They answer it 5 seconds, which is wrong. Okay. So now there is a next question. Object is vibrating at 50 hertz. There is a, what is this? Frequency. Frequency is 50 hertz. So what is the time period? So we want to calculate the time period. How will you calculate time period? It is very easy, very straightforward. I'll tell you the formula. Time period is 1 by frequency. So solve it. Just take the inverse of the frequency, you will get the time period. So what should be the answer? 2 seconds? No. 2 seconds is not correct. So 1 divided by 50. These many seconds. That will come out to be 0.02 seconds, which is option number A. Just a general doubt. If I get 70% overall, boards, okay, you need to be careful with the percentage. So out of 80, if you get 70, most likely your school, they are quite generous. So out of 20, they might give you 18, 19 or 20, most of the cases. And if you are good student, definitely they will give you 20. So if you get 70 plus in every subject, you will be above 90%, correct? Don't say 70%. 70% of 80 would be 56. That is not correct. You should get 70 marks out of 80. Okay, next one is 1 hertz equal to which of the following? If you get 70% overall, okay. Overall means out of 100. 70% of 100 is just 70, right? 70 marks, ace. Okay, 1 hertz. So now these are number of vibrations, and you see here per minute. So now tell me which one is correct. So my suggestion to you is, at least if you are the average student, focus on getting 70 plus marks in every subject. Just focus on getting 70 plus marks. So you will be above 90% overall. Okay, sorry. So 1 hertz is equal to which of the following? 1 vibration per minute. That is wrong. So what is 1 hertz? 1 hertz is nothing but number of oscillations divided by time. So now what is time here? Per minute. But what is the SI unit of time? It is second. So it should be number of oscillations divided by 60 seconds. So now what is number of oscillations? Will be 60 multiplied by 1, which is just 60. So it should be option number C. Nice. Yes, no, a lot of you got it correct. Srinu, nice, awesome. Tubes, nice name. Yes, correct. Great. So one more question and then we'll go to the next topic. Current that always flow in the same direction through the electrical device is called as only in the same direction. Current does not change the direction. It is which current? Tell me. Is it a direct current, alternating current, varying current, magnetic current? So there is no such thing as a magnetic current. Then alternating current, it keeps on changing the direction. Varying current means current value is changing, but it does not mean whether it is AC or DC. So we cannot tell anything about this. So only option left is direct current. And direct current, as you know, there is a battery. You remember our circuit? There is a resistance. So current flows always in the same direction. There is a direct current. Whenever you see this symbol, there is a symbol of a battery. There is a direct current. And if you want to have a symbol for the alternating current, then we use this. So this is the alternating current, AC. This one is DC. So in AC, we do not mention any arrow for the current, because in this diagram or in this circuit, current direction keeps on changing. Can you change the language? Okay, I'll try to speak in Hindi little bit. Okay, so you see this picture. This is a power plant where electrical energy is produced or it converted from the thermal energy or the potential energy. आपको पता है ये power plant होता है, and these are grid cables or the power lines through which the energy flows. So this is not the electrons which comes from our power station to our house. That is not correct. Electrons do not come from the power station to our houses. What comes? It is the electrical energy. What flows? It is the electrical energy. Correct? How does the alternating current? So just assume now, Priyanka. So there was one topic which was electrical generator, which they have dropped from your CBSE syllabus. So in that, if I had that topic, I would have explained. So for now, just assume that it just oscillates. So in alternating current, for example, here, the current oscillates in both the directions. Like the way the pendulum oscillates, to and fro motion. Oscillation is nothing but to and fro motion. So current also oscillate in the AC current, in the AC alternating current. So these are the power stations. So here also it is the AC current everywhere. AC means the current oscillates. Current, sometimes it is going towards our houses, sometimes it is going towards the power plant. Okay, so that is the AC current, alternating current, just AC. So now you must have seen these lines, right? Nowadays in big cities, they have used underground cables. This is more environmental friendly compared to this. This electrical poles earlier they used to have, but it is very bad for the environment, bad for the birds. A lot of birds died or they have some malfunction due to these cables. So nowadays everywhere in big cities they put the underground cables. So what happens? The current comes from the main power supply. So in our houses you must have seen 3 types of cables. So there is a old convention, old color convention for the live wire. There is a neutral wire and the earth wire. It was much easier to remember. Red is like a hot, black is like a neutral, and earth wire, I'll explain you what is earth wire. So it is like a safety device. Kind of you can assume this is like a safe. This was much easier to remember, but now उन्होंने change कर दिया. I don't know why, but they have changed the color combination. So this brown is for the live wire, neutral is like a bluish, and this is yellow green is like a earth wire. Okay, you must have seen 3-pin plug. These 3-pin plug are much useful, or much, I would say, safety, much safer than the 2-pin plug. In 2-pin plug we do not have the ground or the earth cable. So these 3-pin plugs are much safer to use. So do you use 3-pin plug or 2-pin plug in your houses? Which ones do you use mostly? If you are using 2-pin plug, I'll suggest to start using this. This is much safer, and I'll explain you why these are safe. Okay. So there's a, in our houses there's a, these are the 2 wires. This blue one is a live wire. This is a neutral wire, white one. So when the live wire, it is coming from the power station, correct? It is connected to the, so there is a fuse. Do you remember fuse? We have learned the fuse in chargers. Yeah, in small devices it is okay to use 2-pin plug, but let's suppose you have a big device like a AC, or let's say heater or refrigerator, then you should always use 3-pin plug. For bulb, fan, 2-pin plug is okay. So there is an electrical fuse. You remember why we need electrical fuse? To protect our house. This is our house. There is an inside of our house. So when the current, there is an alternating current. So it can fluctuate. Current sometimes can go very large, or it can come very low current. Let's suppose a lot of people are using the power supply, so the current intensity might decrease, but sometimes it can fluctuate. So this fuse is used to protect. Yeah, it will melt, correct. So after this we have electricity meter. Why do we have this? To measure how much energy we have consumed, to track the amount of energy which is consumed. And then there is a grid, or there is a distribution box. So what it does, it separates the devices. Let's suppose there are some devices which require a lot of current. For example, AC or the heater. Then there are some devices which require less amount of current. For example, fan or TV, or let's say bulb. They are not that, they do not consume that much energy. Cuts off supply? No, it is not the voltage, it is the current. You remember Joule's heating effect? I square RT. So the heat produced is directly proportional to the square of the current. So if the current fluctuates, if the current increases rapidly, this wire will melt. That is the fuse. Okay. Tell me again. Okay. Which one to tell again? This one? Okay, I'll again explain you. You see there is a live wire. So this live wire is coming from the power stations. So it always have current. So this wire always have, always have current. There is a neutral wire. It will have the current only when it is connected to the device. If it is not connected to the device, or if the switch is off, then neutral wire do not have any current. Then there is a earth wire. I'll explain you what is a earth wire. So this earth wire is connected to every device. Whenever you have 3-pin plug, there is an earth wire. Okay. So if there is a leakage current, then the leakage current will flow through the earth wire and it will go to the ground or to the earth. Okay. So this earth wire is used to protect the device. So now the potential of the earth wire is 0 volt. So why it is 0 volt? Because it is connected to the earth. Correct? This earth wire is connected to the ground or the earth, and earth is like a sink. So it can consume as many number of electrons as possible. So there is no limit. So the potential is always 0 volt. For the live wire in India, the potential is always 220 volts. So there is a fixed potential. This, you see the amplitude in the AC current. So this maximum is this 220 volts. Okay, the maximum amplitude is 220 volts for the live wire, and for the neutral wire it is always 0 volt. So what will happen? If you connect the live wire and the neutral wire through some device, then the current will flow from the live wire to the neutral wire and the circuit gets complete. Okay, so let's understand that. For example, this is a refrigerator. So now what happens, sometimes there are metallic parts. Some part here might have some metal objects, and let's suppose if the live wire, there is some live wire here, live wire. So if this live wire is connected to the metal, what will happen? The potential of the metal will become 220 volts. So the potential reach to 220 volts. For example, this metallic wire is at now 220 volts. Correct? And now let's suppose I am walking here and I am barefoot. So I am not wearing any shoes or anything. If I touch this, what will happen? Ground, that is the earth, is at 0 volt. So the ground here is at 0 volt, and let's suppose there is a person standing here. So if this person touch, what will happen? The current will flow. There is a higher potential and the lower potential. So the current will flow from this device to the ground and through the body, which is not good. So the person will get electric shock, and to avoid that we use earth wire, which is in green color. So what is earth wire? Neutral wire is negative. Negative, it is just a symbol. So let's suppose if you have the battery, there is a battery, for example. If this one is at 0 volt and this one is at, let's say, plus 10 volt. So still we say this is a positive and this is negative, right? So negative just means it is at a lower potential. That is the meaning of negative. So 0 volt will also used to be negative. So relative, these are the relative terms. So the positive means higher potential, negative means lower potential. So in case of neutral wire, it is at a lower potential. So that is why sometimes it is written as negative. That is not incorrect. Okay. So now what is earth wire? So let's suppose here there is a live wire, and because of that this one is at a 220 volts. So now this charged object. So live wire has lot of free electrons. They will flow to this device or to this metal plate. So now what will happen? If you connect the earth wire, let's suppose I'll use a green symbol. There is a earth wire and it is taken to the ground. There is a ground. So there is a earth wire. So what this earth wire will does? It will pull the extra charges. So the charges can be, it can be electrons, or can be like less of electrons. It can have more electrons, then it will become negatively charged, or it can have less number of electrons. So it would be positively charged. So let's suppose this earth wire can remove all the extra charges. So if it removes all the extra charges and send it to the ground or send it to the earth, so now the potential of this metal plate has restored to the, so this 220 volt will be restored to 0 volt, which is same as the potential of the ground, which is 0 volt. So if you connect these two, both of them will be at a 0 volt. So now this device is safe. So you don't have to worry about it. Okay. My name is Akash. Alright. So now it prevents this earth wire prevents users from the electric shock. Alright. So you see there is a lightning. If there is a lightning, this is a lightning tower. This is connected in the ground. There is a metal plate which is buried deep inside the ground. This is our lightning cable. This is connected to all the houses. So these are all our earth wires. So it will collect all the extra charges from all the houses and send it to the ground. Okay, this is how we protect the building or protect all the devices in our house. Okay. So now transfer of leakage current. Yeah, okay. There is the earthing. This process is called as earthing, which transfers the leakage current to the ground. Let's solve few questions based on this. Why does the current increase? Yeah, just give me 5 minutes. Priyanka will come to the short circuit and then I'll explain. Just 5 more minutes, I'll explain that. So in which of the following wires will always have electric current? Is it the live wire, neutral wire, earth wire, and all of the above? So the neutral wire and earth wire do not always have current. They will have current only when they are connected to certain device. But which wire will always have the current? It is the live wire. So it is very like childrens must be kept away from this live wire, because only single wire is enough to give electric shock. You don't need a neutral wire for electric shock. Next one. So the current rating. What is current rating? So different devices. For example, this is a heater, AC. They use higher current. So there is a 15 ampere rating. That means if you want to protect these devices, you use a fuse which has a rating of 50 ampere, or you remember the grid shown at the beginning. So this grid or the distribution, so here you mark, let's suppose this is a 15 ampere, this one is let's say 5 ampere, this one is let's say 1 ampere. So this is the distribution board. So this 15 ampere will go only to the devices which use lot of current. For example, AC or heater. 5 ampere will go to the medium size devices and 1 ampere to the very low devices like a small bulb or something. Okay. At least 15. Fuse of, no, there is a maximum, I guess. Yeah, there is a maximum 50 ampere. In our houses, we do not need 50 ampere is lot of current. We do not require this much current. If you want to go above 15 ampere, then those will be industry level fuse. Correct? In our houses, we do not require this much current. Even this 5 ampere or within 10 ampere current is sufficient to run the AC or the heater. These are the small devices. They can work with 5 ampere, or if required, you can use a fuse of a lower ampere as well. Yes, music lover, you have question? Just ask a question. Don't say I have question. Just ask. I'll be happy to read. Okay, solve this question. Just ask a question, music lover. Because of short length of the wire. Okay, we'll go to that chip. Priyanka, just 5 more minutes. Let's solve a couple of questions, then I'll go to that. Which type of current rating supply is required for geyser and electric iron? So electric iron or geyser, they work on the principle of heating effect of current. So we need lot of current. So which of the following will be required? What do you think? 50 hertz and 220 volts. These are not the current rating. We want the current rating. And for the devices which use lot of current, we need 15 ampere rating. Okay, these are not the current rating, 50 hertz or 220 volts, they are not current rating. Yes, nice, dupes, Priyanka, awesome. So now, what are the hazards of these domestic circuits? There are two hazards, overloading and short circuit. So let's understand what is overloading and what is short circuit. Have you done this, any one of you? In our houses, have you done this? Or have you seen anyone doing this in their houses? This is called as overloading, electric overloading. So you see, there is a single charging point, and through that, I don't know, 1, 2, 3, 4 devices are connected from a single plug. It depends. Usually electric iron need lot of current, because current need to pass through it, then only it will get heated up. Okay, dupes. Fleming's right hand rule. No, we are not using here Fleming's right hand rule. Or you want me to explain? Okay, maybe after this I'll explain you again. Fleming's right hand rule. Fleming's left hand rule, right? Not right hand. Right hand is for the electric induction, which is dropped from your syllabus. Don't worry about that. So it is not in your CBSE board exams. So right now, don't worry about it. Right hand rule. Fleming's right hand rule. So what will happen because of this? If it is overloading, it might catch fire. So why? Because let's suppose the rating of this plug is 1 ampere or 5 ampere, but you are withdrawing current of 15 ampere. So if you are withdrawing lot of current from this small device, small socket, then that is overloading. So it might get overloaded and might catch fire, like as you see, there might be spark coming out from it. That is overloading. Next one is short circuit. So what is short circuit? Priyanka, you are asking, right? So you see this one is live wire and this one is neutral wire. Live wire always have the current and it is at 220 volts. This one is at 0 volt. So now by like somehow these two wires, they just got connected. So what will happen? This is called a short circuit. So if these two wires come in contact, if let's say there is a damage for the insulation, so there is a plastic or rubber, right? Inside of this there is a metal wire. So if that metal wire, you see these two metal wires, these two metal wires, they came in contact with each other. So what will happen? Suddenly lot of current will flow from this and come to the neutral wire. So lot of current will flow, and because of that, what will happen? This process is called as short circuit. When the live wire and the neutral wire come in direct contact, so it might create lot of spark, might create lot of heat. These devices might catch fire. Lot of things can happen. And when does this happen? So current in the circuit abruptly increases. Let's suppose the neutral wire is connected to some device. Let's suppose there is a bulb or TV connected to this neutral wire. So that TV might explode because of sudden increase of the current. You have no control over it. So if it comes through the proper channel, proper distribution board, then it is safe. If it comes like this, there is a short circuit. So that device might burn, it might catch fire. Okay. So this process is called as short circuit. Clear, Priyanka? You are asking this? Omit, yeah, induction, electric induction or electromagnetic induction, that is removed from your syllabus, deleted, correct. So don't worry about it. If you are very interested, you can read it, but after your exams. Right now, it's time to focus on your exams. Get done with your exam first, and after that, whatever topics which were deleted, you can again go back. Why does the current increase? Okay, Priyanka, if something is, let's say this is at 220 volts and this one is at 0 volt. If you connect these two, what will happen? Current will flow, right? from 220 volts, which is higher volt, which is our live wire, and 0 volt is nothing but our neutral wire. If they get short, there is a short circuit. Short circuit means there is no resistance. Short circuit means resistance value is 0. If the resistance value is 0, the potential difference is 220. You remember Ohm's law? So Ohm's law says the current is equal to voltage divided by resistance. Short circuit means the resistance value is 0. If the resistance value is 0, can you tell me what is the current? It is 220 divided by 0 ohms. So the current will be very large. It won't reach to infinity, but it would be very large current. Understood now? Okay, so now this hazard prevention fuse. So these are the older ones. These are little newer ones, newer fuse, and this is even better, MCBs. But this is a bit difficult to understand right now. So we'll not look at this MCBs. But in our houses nowadays, in modern houses, they prefer MCBs than the fuse. I'll just tell you in short why MCBs are better. In fuse, this wire, it melts. Whenever a lot of current flows, this wire melts. This wire melts. Once the wire melts, this fuse is no more useful. You cannot use it again. This is not reusable. But these MCBs, they are reusable. So it just trips. This thing just trips down. So you can reset it or trip it upwards. So you can reset it and you can use it multiple times. But it is difficult to understand right now. So we are not going to study this. Alright. Okay, last few questions and then we are done for the day. Yes, low melting point, correct. For the fuse. Does same amount of current flow in live? Yes, it has to complete the circuit, right? Okay, so Jai, there is a difference. In DC, it is the same current which flows. In AC, it is fluctuation of current. Or current just, let's suppose there is a power station and this is our house. So they are connected with the live wire. So the current is always in the to and fro motion. So that is the oscillation. So do you know how much time it takes for the current to reach from the power station to our house? Any idea? Any idea? How fast current travels? So it is not the current which travels from the power station to house. Current fluctuate, current oscillate or vibrate. What is the thing which travels? It is the electromagnetic wave. And these waves has the same speed as speed of light. That is why they are very fast. Okay. Alright, there is something extra. But nowadays I have seen, have you guys seen the sample paper? The questions are really tough, okay. I can tell you about the physics. Questions are quite tough. And you should be very careful reading all the questions. We are going to start, MCBs are reusable. We are going to start doing the practice session for the sample paper from, I think, after a couple of days, from 2nd February. Okay, tomorrow we are going to have a Menti quiz. So all of you, I want you all to be there tomorrow. Okay, let's solve this fast and I'll tell you what are the things we are going to come up with in the next 2 weeks. Okay, so electric meter, very simple. It is used to track the electricity. Electricity is nothing but electrical energy. We need to track how much energy is used. That is the electricity. Yeah, sprint station. Nice, you know it. Okay, I'm going to tell you, just give me 5 minutes. I'm going to tell you all the things we are coming up with. Short circuit takes place due to which of the following? Touching the live and the neutral wire in the circuit. Sudden flow of very large amount of current. Damaged wiring or all of the above. Very fast. Factors of resistance depend on. Music lover, there are 3 factors: length, area and the resistivity. If you want more, you can go back and watch the electricity, I guess, first lesson on the electricity. So short circuit takes place due to all of the above. Because of this, this and this, so it is option number D. All of this. If there is a damaged wiring, then what will happen? Whenever you have a damaged wiring, the live wire and the neutral wire, they come in contact. And when they come in contact, what will happen? Large amount of current will flow. So all of the above is short circuit happens due to all of the above. Alright. So fuse wire is inserted in which of the following? Live wire, neutral wire, earth wire may be connected in any wire. You see, this is the live wire, this is the neutral wire, and let's suppose we have a 3-pin plug. So this is the earth wire. This is live, this is neutral. So the fuse is connected in which? So if you connect with the neutral wire, will it prevent? Let's suppose I have to use it in neutral wire. Will it prevent our device? No. So neutral wire is not correct. Hot earth wire? No, earth wire is removing the extra current. So it is not required. How about the live wire? If I put a fuse here, then it protects the device because live wire will always have current. So we need to add a fuse at the live wire. So this one is correct. Okay. Sudden flow of charge. Yeah, it is same. Overloading is just that. Let's suppose कोई एक डिवाइस है जिसका करंट रेटिंग इज 5 एम्पियर्स एंड आपने अगर बहुत सारे डिवाइसेस उसको कनेक्ट कर दिए विच इज नॉट सजेस्टेड बट आपने अगर कर लिया वैसे जय तो दैट इज ओवरलोडिंग. सो दीज आर नॉट वेरी डिफरेंट. व्हाट इज शॉर्ट सर्किट? शॉर्ट सर्किट में क्या होता है? इफ आई गो बैक इन द शॉर्ट सर्किट there is a live wire. So live wire will have, so for example there is a coating of the live wire and there is a material, there is a wire and this one is coating or insulation, correct? There is a live wire and similarly we have a neutral wire, there is a coating and there is a neutral wire. So this live wire is always at 220 volts. This one neutral wire always at 0 volt. So by chance, let's suppose if there is a damaged wiring, that means this insulation or this coating is removed. Then what will happen? These two wires, they will connect. If these two wires connect, so there is a touching of live and neutral wires in the circuit. If these two wires connect, what will happen? There is a higher voltage and the lower voltage. Suddenly lot of current will flow. I told you just now, like 5 minutes back, if the resistance is 0 or almost 0, then the current is very large. From the Ohm's law, what is I? V by resistance. If the resistance is 0, current is large current. So there is a sudden flow of large amount of current. So all three of them are correct. Okay, the last one. The fuse is inserted in, there is a fuse inserted in the live wire to prevent the devices in our house. बारिश आने वाली है. Okay, just coming to end. Alright, I am going to tell you what we are going to do next. So tomorrow we are going to have a Menti quiz at 3 p.m. It is maths and I think at 4:15 sharp we are going to start with the science quiz, science Menti quiz. And day after tomorrow, there is a marathon. In 6 hours, or I don't know, in maybe 8 hours, we are going to finish complete revision for the science and maths. In 8 hours, complete syllabus for the whole year. So all of you should be there. And after that, we are going to do a sprint. So we are going to solve the question papers, like some sample papers which are available, provided by the NCERT and some sample papers which we have prepared. The Sri Chaitanya and the Infinity Learn, we have prepared some sample papers. So we are going to solve all of them. Alright, so that's it for today. Thank you so much everyone. Bye bye.